Hello everyone. This video is about flat Earth versus globe Earth. I believe in globe Earth and hope to convince other people of that shape. I've talked a lot with flat Earth people lately and listened to a lot of their arguments, and I don't think they hold up. I'll introduce myself a little in a way that I feel is relevant to this video. I grew up in Southern California, and my dad worked in aerospace there. He did work on the space shuttle there, and I got to see it in construction. I know that does not prove that the shuttle went into space, but my dad worked on it. He thinks it went into space, and he's pretty awesome. So there's some bias on my part. I am a programmer, computer programmer, and that means I don't do physical sciences, but I do think that I'm used to thinking critically about things and finding a problem. I don't worship science, and I know that that might matter to a lot of flat earth people. I have thinking that is my own that I trust over so-called experts. And I think that nobody can do better than to think the way they do until they're properly convinced otherwise. It doesn't matter what everybody else says as long as your own reason has not been convinced. I do think that some scientists get away with crap, such as climate change scientists. I don't claim to know that climate change is not real. However, what I do know is that some of those climate scientists said that the polar ice would be long gone by now. Yet we still take them perfectly seriously and look to them for salvation. So why do I think the Earth is a globe? Well, there's a few main things. In this video, I only have one that I will talk about, and that is the path of the sun, the moon, and stars. I feel like that I have first-hand knowledge about these things that prove that the Earth is a globe, and I'll get into that in a second. Okay, the things that I feel I know about the sun and prove a globe Earth are these: constant angular velocity through the sky, rise and set azimuth and elevation, constant size, and stars in the south. A quick overview. Constant angular velocity means that as the sun progresses through the sky in this manner, it does so in a very regular fashion. It's not going slower here or faster here or anything like that. I have done a lot of hikes where I could observe the sun at various times, and I started to try to learn how to do timekeeping with the sun, because I had a Boy Scout leader who was very good at it and had some interest in that. And bottom line is, I feel like I know that this motion is regular. The rise and set azimuth and elevation. Azimuth means direction east or west. So let us consider this a piece of ground that I'm standing on. As the sun goes through the sky, it's going to rise at a certain point. And a bottom line is elevation refers to how high it is when I see it rising. And it's below me. Anyway, the azimuth is the specific location, and at this time of year, we're still pretty close to equinox. I'll see it rise dead east.
Daddy, draw your
And then
head.
it goes through the sky. It doesn't necessarily do it precisely straight at this time of year. That's an exaggeration, perhaps. And then the azimuth of the set at this time of year is also due west. I feel like I know this. And the interesting thing is that at equinox, everybody has these same bearings, which is, in my opinion, impossible on a flat Earth. The other things that I will mention briefly are that the sun has a constant size throughout the day. It never appears to get closer. If it's this size at rise, it's still this size at noon, and not something considerably bigger. Now, stars in the south, I'm starting to trust other people when it comes to this topic. I don't have personal knowledge like I do with these other topics. I'm going to cover these topics in more detail right now. Regarding the constant angle of the sun's motion through the sky, whether at noontime or evening time, you don't have to take my word for it. There's some experiments you can do to test it yourself. One of them is the equatorial sundial. It's a dial that is situated at a specific angle for your latitude. And this portion here casts a shadow down on the dial face, and as the day progresses, it moves it at a constant angle. I will do one render here, a low quality one, so that it doesn't take forever. But as you can see, the angle here is at some angle, and I'll move the sun backward in the sky a couple frames. So once again, in the real world, you can place one of these equatorial sundials with the dial face facing north at the specified angle, and you will be able to observe the shadow moving at the constant angle. Now, if you don't trust this equatorial sundial, and I could understand if you don't, I mean, it is placed at an angle that you might find suspicious. But maybe what's key here is that this sundial situated for this latitude works in reality and does not work in this flat Earth model that I've created. So to me, whether or not you trust this sundial, you have to appreciate that the result in the simulation is different from reality. Now, if you don't want to trust the sundial at all, here's another experiment you could do. Sometime near noon, point a camera up at the sun. I mean, I'm not responsible if you damage your camera doing this. I don't know what they can take. Wait 15 minutes and take another picture. Here's picture 1, picture 2. Take another picture without moving your camera at all. Do not move it. And then you could composite those two images on top of each other, and you would be able to see the distance in this picture, how far it's moved. Then later, some other time in the evening, get your camera and point it straight at the sun. Take a picture, picture number 1. Wait 15 minutes again, or whatever. Take picture number 2, once again without moving your camera at all. Composite the two images, and then you'll be able to observe that this has moved as far as this. If you want, you can observe the moon. Observing the moon is much safer. It's not going to damage your eyes or anything else. And watch it rise. You'll be able to verify angles, both near the horizon and up in the sky. But one of the things that you'll be able to do is also compare the sizes. So as the moon goes way, way up, gets over your head, maybe over here, you'll be able to verify that the size of this moon is not smaller than this moon. If anything, your perception says that it's bigger down here, which is actually a trick. But one thing that you should feel sure of is that this moon here is not closer than the moon you see down here, as I believe would be predicted on a flat Earth model. Because if this moon is, say, 3,000 miles up, which I don't know what exactly they propose for the moon, and you have another moon over here that's 3,000 miles up, and maybe it's 1,000 miles distance, then your distance to that moon is going to be this, as opposed to this. One of the great things about the moon is that it doesn't overexpose lenses. I've seen a few flat Earth videos where the sun rises and yes, it appears to get a lot bigger. But that's an overexposure issue. If you do it with the moon, you will not get that overexposure and will be able to do the size comparison without getting tricked. Here's how I think the sun would behave on a flat Earth due to perspective and how it differs from reality. Now, say that the sun is traveling a set speed, and let's say that it travels this far in an hour. He's going to first observe the sun at this location, and then wait an hour and observe it at this location, and this is the angle difference. Then, at some time, our guy would see it at this angle, and then an hour later would see it at this angle. Now, as you can see, this angle here is very much less than this angle here. While it's true that eventually this sun would approach the horizon, as you can see, it's already gotten a lot closer compared to noon. That sun would have to get way the heck out there in order to approach the horizon. I don't know. If we consider this angle, then I need the sun to be several laptop screens away before it's at its true elevation. But anyway, this lessening of angle in the evening is not what we observe in reality. In reality, we do see the sun fall the same number of degrees in 1 hour as it did over here. There's only two explanations. Sorry, I started with one explanation. Either the sun is not getting any lower and it is starting to go way faster as it gets out here. But then that would be a problem for other observers where the sun is then. Or the sun is, in fact, not traveling in a straight line. Okay, forgive this crude drawing. That's what you get when you get low budge me.
I had it draw.
Okay, just a minute now. So this is me standing on a piece of ground looking west. And this is not to scale. In reality, I would just be a little dot standing there. So as I'm looking west and I see the sunset, I have the impression that the sun goes below my head. Now that impression, you might say, is pretty juvenile, but it's at least on par with the flat earth people saying to me the earth looks flat. Well, it is equally valid for me to say, to me, it looks like the sun goes down under my head. But the sun, as it goes below me, is going over someone else. And that means one of two things. Either they're standing way the heck down here, whoopee, and maybe standing at the same angle as me, but nobody believes that. Or else they're standing at a different angle than I am. It's just a given. Now it's over their head and below mine. You can continue this until the cycle is complete. And maybe someone sitting over here in Ukraine sees the sun going below their heads. And it's my turn again to have the sun over mine. And this is not just pure conjecture on my part. I work with people in the Ukraine, in Ukraine. Don't say the Ukraine. And we have video calls. And often in our meetings, we can see that the sun has set or is setting for them. And meanwhile, it's coming up for us. So in my real world experience, I have this impression cemented in my head that I am not standing at the same angle as people in Ukraine.
Daddy.
Now, to me, it's strongly intuitive that a flat Earth model cannot explain the path of the sun and moon. Still not trusting my instincts, I created this simulation in Blender. This is the sun. It is at about 3,000 miles up, and it's at equinox. It goes around roughly the equator. I placed an observer down in the Salt Lake area. Let's get over there. Alright, that's the observer over there. And we'll go ahead and enter it in just a sec. Okay, let's enter it. Alright. Couple of quick explanations. This is the sun. This is a compass, which tells you which direction we are looking. And there's this little strip here, which is a gauge, which tells you when the sun should be rising and setting. Let's make some observations. The gauge has turned red, meaning we're nearing sunset, and there is set right there. Well, that's where it should be. However, we're still well above the horizon here. There's another problem, which is that we are looking very much more to the north than we should be. We should be looking straight west on this compass. Back here, before, at the time of set. should be night this whole time. And right there, we should be rising again. Another problem to note is that we never were below the horizon. Another thing is that we are looking northeast. We should be looking straight east. Now, I believe I've correctly modeled these things in Blender. You're free to criticize the simulation. I've made it available for download. And if there's a problem, you can tell me what it is and tinker with it and fix it even. And if you do that, I will be very happy to reconsider my conclusions. So I'm just going to let it spin for a while, and I will talk about my conclusions again. Number one, at set, we are looking northwest instead of west. Number two, at set, it never goes below the horizon. Number three, at sunrise, it's never been below the horizon. Number four, at rise, we are looking northeast instead of east. Number five, which I didn't mention before, is that the size of the sun there changes in the sky as we go around. And that is not observed in reality. If you like, instead of thinking of that as the sun, you could say, well, this is the moon now. And you can then feel very sure that its size should not be changing like this. So, there are problems when you try to model the sun on a flat Earth. And to me, that is the elephant in the room. Literally, nothing else matters, unless you can get the sun to set where it belongs and rise where it belongs. Literally, nothing else matters. I cannot accept a flat Earth model that does not fix this problem. I have heard of one proposed fix, which is atmospheric lensing. Lensing bends light, and so if the sun is up here, we need a lens that will make it appear down here, where it belongs. And Blender allows you to put lenses in the system, but I just couldn't figure out a lensing system which I felt would work. I would love for any of you guys to create a lensing system, and I will re-render and see if you guys have been able to make it work. But I would remind you, your lensing system not only needs to correct this elevation, but in my mind, it also has to correct the bearing. We need the sun setting down here, not over this way. If you accomplish that feat, number one, I'm going to be impressed. But the first thing I'm going to do is I'm going to take this observer and I'm going to move him down to Australia or something. And then maybe I'll move him to Africa, South Africa down there. Then if you pass those tests, if you haven't messed these observers up, then the next thing I'm going to do is take the sun and I'm going to move it out from equinox to different seasons. I'll put it down at winter solstice and summer solstice. See if you still haven't screwed up. The very last thing I'm going to do is check whether you have duplicated constant angular velocity through the sky, and whether you have managed to keep this a constant size. Now, you might say, well, it shouldn't be a constant size. In your mind, you could say, all right, this is not the sun now, this is the moon. In the moon's case, you should be able to feel very sure that the size should not be changing in this manner. So I want your lensing system to pass that test. In other words, your lensing system needs to work for all locations, for all seasons, It needs to correct the sun's elevation and bearing. It needs to fix constant angular velocity through the sky. It needs to create a moon that does not change sizes as it moves through the sky. If you accomplish all that, you have my profound respect. And I would have to admit that you have reopened the door of possibility that maybe this could be reality. However, I would be back to faith at that point. There's absolutely no ability for me to prove or disprove that, and I would be taking your word for it that this lensing system is making this possible. I would also say that if you take that lensing system seriously, you have to stop teasing round earth people for inventing something called gravity, because then you have invented a very complicated lensing system to make your model a possibility. And for consistency's sake, you gotta stop teasing. And the final thing I would say is, if such a lensing system is in fact in reality, it exists in the real world, then I would ask God, why? Why did you do that? You created a system which was designed in every way to convince me that the earth was round and that the path of the sun was angular. You made it appear a constant size when in fact it wouldn't normally be. You made it have constant angular velocity through the sky when that is not something that would happen normally on the flat earth model. Why did you do all that? It's like you were laying a trap for me. But the bottom line for me is, I don't believe that. Okay, here we are at the south of South America, and although I don't have a sky dome here, and I wasn't exactly sure how you guys model stars anyhow, but here's some things I feel. I feel like that people in South America would still clearly see Polaris as they're looking north. They would still see, if they took a time-lapse picture, that famous star circle, and it would be around in the north. Now, I trust people when they tell me that they do not see Polaris in the South Pole, or at least it doesn't look like Polaris to them. What's even more important is that they tell me when they look south, they see a constellation called the Southern Cross, somewhere over here. I don't know where exactly. And I'm going to trust them on that. And they tell me that as they look at that constellation and take a time-lapse photo, they see the famous star circle down in the south. I guess that means that the Southern Cross is off this way. But wait, people in Australia tell me they see the Southern Cross and the star circle, so I guess that means that it's off this way. Oh, but wait, what about people in South Africa looking south? Maybe the Southern Cross is off in that direction, and the rotation is based there. Bottom line is, your starscape, in my mind, is utterly broken. I believe people in South America would still see Polaris. I believe that they would still see the star circle in a time-lapse picture off to the north. I believe that getting a star circle that works while looking south is impossible, because you've got to get it working for people in South America, for people in Australia, for people in in Africa, South Africa. So are you proposing a local piece of the firmament that spins down in the south to create that circle? So the path of the stars, in my mind, indicates a globe as well. I do not believe that the observed starscape, or at least what I have had reported to me, because I have not personally observed this, is that it cannot be explained on a flat Earth, but can on a globe. You can't get little circling star systems out here at the periphery, which let these people here all look their direction south, all see the Southern Cross, all see that circular, or see that rotation around the Southern Cross. It's just one more nail in the coffin for me thinking that this is reality.